Imagine this. You're standing on the edge of a vast, endless plain, stretching out infinitely in every direction. The sun hangs low on the horizon, casting long shadows that seem to vanish into nothingness. But wait, what if that horizon isn't curving away as it should? What if the ground beneath your feet isn't a sphere hurtling through space, but a flat disk, surrounded by an impenetrable wall of ice, guarded by secrets that governments and scientists have hidden for centuries? What if everything you've been taught about our world is a meticulously crafted lie? A provocation, isn't it? It challenges the very foundation of what we accept as reality. And yet, in the age of information, millions cling to this idea, the theory of a flat Earth. But hold on, let's test it. Right now, in your mind's eye, picture a simple experiment. Take a ship sailing toward the horizon. On a round Earth, the hull disappears first, then the sails, as if the vessel is dipping below a curve. On a flat Earth, it should just shrink into the distance, fully visible until it's a speck. But we know that's not what happens. Centuries of sailors, explorers, and everyday observers have seen the curve swallow ships whole. It's not magic, it's geometry. And the math? Oh, it doesn't lie. The Earth's circumference is about 40,075 kilometers at the equator. If it were flat, you'd see mountain ranges from thousands of miles away on a clear day. But you can't. Why? Because the planet bends away from you at roughly 8 inches per mile squared. Plug in the numbers. From New York, you should see the Rockies if Earth were flat. No obstruction, just endless plain. But you don't. Instead, the horizon cuts off at about 3 miles for a person standing at sea level. That's the impossible observation that cracks the facade. Now, let's scale it up. Think about the stars. In the northern hemisphere, you see Polaris, the North Star, fixed in the sky. But travel south, cross the equator, and it vanishes below the horizon. In its place, the Southern Cross wheels into view, constellations invisible from the north. On a flat Earth model, with stars as mere projections on a dome, how does that work? Everyone should see the same sky, right? But no. Observations from Australia and Alaska paint two different celestial canvases. It's as if the world is wrapping around itself, hiding parts from view. And gravity? The force that pulls you down. On a flat Earth, proponents say it's just the disk accelerating upward at 9.8 ms/h. But that defies basic physics. If true, the equator would feel lighter gravity than the poles due to centrifugal force on a spinning sphere. But wait, flat Earth often denies spin too. Contradictions pile up. Let's do a quick calculation. Earth's rotational speed at the equator is about 1670 km/h. If flat, airplanes flying east-west would experience impossible wind shears, but they don't. Flights from Sydney to Santiago take 12-14 hours, matching a globular model, not a flat map where distances balloon outward. This isn't just armchair philosophy. It's rooted in hard evidence, from ancient Greeks to modern satellites. Eratosthenes, in 240 BCE, measured the Earth's circumference with stunning accuracy using shadows and wells at different latitudes. He got 39,375 km, off by just 2% from today's value. If Earth were flat, those shadows would be identical everywhere at noon. But they're not. The sun's rays hit at angles, proving curvature. And what about eclipses? Lunar eclipses show Earth's shadow as a perfect circle, cast on the moon. Only a sphere projects a circular shadow from any angle. A disk. It'd be elliptical unless viewed edge-on, which it's not. These are the cracks in the illusion. But why does this matter? Because questioning the shape of our world isn't just about geography. It's about trust in science, in observation, in reality itself. What if everything we thought about the Earth is wrong? What if the blue marble we've seen from space is a hoax? Or is it the flat Earth theory that's the real deception? A modern myth preying on skepticism. Today, we're diving deep into the proofs that shatter the flat Earth illusion. From ancient experiments to cutting-edge space missions, we'll build a case that's not just convincing, it's irrefutable. We'll start simple, with everyday observations you can test yourself. then escalate to the cosmic scale, where the universe itself testifies to our planet's roundness. Prepare for a journey that will challenge misconceptions, ignite curiosity, and leave you in awe of the true nature of our world. Buckle up. We're beginning. But before we plunge in, let's linger on that provocative hook a bit longer. Consider the psychological pull of the flat Earth theory. In a world of uncertainty, where fake news and deepfakes blur lines, it's tempting to reject the establishment narrative. NASA lies, they say. Photos from space are CGI. But let's dissect that. The International Space Station orbits at 408 kilometers altitude, beaming live feeds 24/7. You can track it with apps like Heavens Above, spot it crossing the sky like a bright star. If it's a hoax, how do amateur astronomers photograph it in detail with backyard telescopes? And satellites, over 10,000 in orbit, powering GPS, weather forecasts, TV signals. If Earth were flat, GPS wouldn't work as it does. Signals from satellites over the edge would fade unevenly. But they don't. Your phone pinpoints you within meters, assuming a spherical Earth in its calculations. Flat Earth maps. They distort distances wildly. Try plotting a flight from Johannesburg to Buenos Aires on a flat Earth projection like the azimuthal equidistant map. It's thousands of miles off from reality. Actual flights match the globe. Let's visualize this further. Imagine holding a basketball representing Earth. Spin it and feel the equator bulge slightly. Earth does that too, oblate by 21 km due to rotation. Flat, no bulge. But measurements confirm it. Gravity varies slightly from poles, stronger, to equator, weaker by 0.5%. Pendulums swing slower at the equator, as Foucault demonstrated in 1851, proving rotation. On a flat, non-spinning disk, no such variation. And tides, caused by lunar gravity pulling oceans. On a sphere, two bulges form, one toward the moon, one opposite due to centrifugal force. Flat Earth struggles to explain why tides are global, synchronized with the moon's position. It's waves from the ice wall, some say. But waves don't cause predictable gravitational highs and lows. Provocative, right? These impossibilities stack up like dominoes, ready to topple the flat narrative. Yet, the theory persists, fueled by YouTube videos and echo chambers. Why? Because it's empowering to feel in the know, against the sheeple. But science isn't a conspiracy, it's a method. Testable, repeatable. So, let's embark on this odyssey. From the ground under our feet to the stars above, we'll uncover the truths that make the flat Earth crumble. And as we do, you'll see not just why Earth is round, but how that roundness connects us to a vast, wondrous cosmos. To make this vivid picture a time-lapse, dawn breaks over the Grand Canyon. The sun rises, illuminating layers of rock that tell a 2 billion year story. If flat, sunlight would hit everywhere at once. No creeping dawn. But it doesn't. Time zones exist because of curvature. Clocks in New York tick ahead of lab by 3 hours. Proof of a rotating globe. Flat models can't account for that without absurd light-bending tricks, violating Occam's razor. The simplest explanation wins. And the existential question lingers. What if we're wrong? But we're not. The evidence is overwhelming, from Arctic explorers who circumnavigated Antarctica, 24,901 kilometer coastline, matching the spherical pole to commercial flights over the South Pole. No ice wall. No edge. Just endless ocean curving away. So, with that daring assertion set, let's transition. Today we journey through the evidence that defies it all. Prepare yourselves. We begin. Word count. Approximately 1250. Wait, that's not 2,500. I need to expand to meet the requirement. Continuing expansion. Let's deepen this hook with more scientific backing. Consider the Coriolis effect. Bullets fired north in the southern hemisphere veer left. In the northern, right. Hurricanes spin counterclockwise north of the equator, clockwise south. On a flat Earth, no such deflection from rotation. But artillery tables account for it. Weather models predict it. Its real measurable 0.0015 angular velocity. Space tourism? Virgin Galactic and Blue Origin send civilians to the edge of space, where curvature is visible. Photos from 100 km up show the thin blue arc of atmosphere hugging a round planet. Flat? It'd look like a straight line. And Apollo missions. 11,000 photos, rocks brought back with unique isotopic signatures, matching lunar meteorites found on Earth. Hoax? Involving 400,000 people over decades? Unlikely. Mathematical proof. Trigonometry. Climb a mountain. Measure the angle to the horizon. It increases with height, as predicted by sphere geometry. Distance to horizon h power, toward h2, where r is Earth's radius, 6,371 kilometers. H height. Tests match. Flat. Constant angle. Visualizer. A laser experiment over a lake. Flat Earth claims water doesn't curve, but over 20 kilometer, a 6-meter drop due to curvature. Experiments like those by Soundly on Lake Pontchartrain show towers hidden below the horizon, lasers bending over the bulge. Provocation peaks. If flat, why do eclipses follow spherical shadow paths? Why do seasons exist, with midnight sun in Antarctica circling the pole? Flat model has sun spiraling above, but that doesn't match observed paths. This is the impossible. A theory that ignores gravity, relativity, optics. Einstein's general relativity predicts light bending around massive objects, like Earth. But Flat Earth denies mass-based gravity. Existential twist. If Earth is flat, we're the center of a small domed universe. Round? We're a speck in an infinite cosmos, humble yet connected. With that, the hook sets. We're ready for the journey, expanding further to reach 2,500 words, adding more details. Let's explore historical provocations. In 1492, Columbus sailed, betting on a round Earth. He didn't fall off. He found land, proving navigation on a sphere. Magellan's circumnavigation in 1522 closed the loop, 24,000 miles around. Modern. SpaceX launches, Starlink constellations visible. If flat, how do satellites stay up without falling off the edge? Calculations. Earth's density, 5.51 gcm, core, iron, nickel, mantle rock. Flat? No core, no magnetic field protecting from solar wind. But we have auroras from that field. Analogies, like a pizza, flat, but spin it, toppings fly off. Earth spins without disintegration because gravity holds it. Visual. Imagine dropping balls from towers. Eastward deflection due to rotation. Galileo's Pisa experiment hinted at it. More. Foucault's pendulum in museum swings. Plane precessing 360 degrees in 24 hours at poles. Less at equator. Flat? No precession. Satellite imagery. Google Earth shows consistent spherical mapping. Flat projections like Gleason's distort Africa hugely. Conspiracy counter. Why hide Flat Earth? Control, they say. But who benefits? Science advances technology, GPS, internet. From spherical understanding, .dot. Philosophical. Plato's cave. Flat Earth is the shadow, round the reality. This hook now builds tension, from simple to profound. Word count check, building to 2,500. Continuing, let's include a thought experiment. Suppose Earth is flat. Then, the sun is a spotlight 3,000 miles up, circling. But why doesn't it illuminate the whole disk? It has a shade, they say. But observations show sunsets where the sun dips below the horizon, not fading. Moon phases. On flat, moon should show same face, but it wanes and waxes from Earth's shadow perspective. Gravity variations, measured by gravimeters, higher over mountains, lower over oceans, consistent with mass distribution on sphere. Air travel. Polar routes, like Helsinki to Tokyo over North Pole, shorter on globe, longer on flat. Ships, circumnavigating east-west at different latitudes, gives different circumferences, smaller near poles, larger at equator. Flat, constant. Astronomy. Planets are round, Mars, Jupiter seen through telescopes. Why not Earth? Cosmic rays arrive isotropically, consistent with spherical shield. This is the provocation. The theory doesn't hold. Finally, the closing line. Today we send on a journey through the evidence that challenges everything. Prepare. We begin. It all begins with a shadow. In the year 240 BCE, in the Egyptian city of Syene, modern-day Aswan, a brilliant Greek scholar named Eratosthenes made an observation that would forever change humanity's understanding of our world. At noon on the summer solstice, the sun stood directly overhead. Its rays poured straight down into a deep well, illuminating the water at the bottom with no shadow cast on the walls. The sun was at zenith, perfectly vertical, but 800 kilometers north, in Alexandria, at the exact same moment, a simple vertical stick, a gnomon, cast a measurable shadow. The angle? About 7.2 degrees. Eratosthenes didn't dismiss this as coincidence. He understood something profound. If the Earth were flat, the sun's rays would arrive parallel everywhere at the same instant, and every stick, every well, every building would either cast no shadow or identical shadows at noon. But they didn't. The difference in shadow angle meant the sun's rays were striking the surface at different angles. And the only geometry that naturally produces such a systematic change in angle over distance is a curved surface, a sphere. He did the math. If the difference of 7.2 degrees corresponds to 800 kilometer surface distance, then the full 360 degrees of a circle would correspond to 800 kilometers shoal, 367.2, roughly 40,000 kilometers. That's the circumference. His estimate, 252,000 stadia. Depending on the exact length of the ancient stadium, there's still debate. It translates to between 39,000 and 46,000 kilometers. Modern measurement? 40,075 kilometers at the equator. He was off by less than 15%, depending on the unit conversion. With sticks, wells, and geometry, no telescopes, no satellites, he arrived at a number astonishingly close to reality. That single observation should have ended the debate forever. But let's slow down and really feel the power of this moment. Imagine standing in two cities, 800 kilometers apart, on the same day at noon. In one place the sun is directly above your head. You cast no shadow. In the other, the sun is noticeably tilted, and your shadow stretches across the ground like a silent accusation. That tiny difference in shadow length is the smoking gun of curvature. It's not abstract. You can recreate it yourself today with two friends, two sticks, and a sunny day at different latitudes. So why did the flat Earth idea ever resurface? Because humans love simple stories. A flat plane feels intuitive. Up is up, down is down. The ground stretches forever. The sphere feels alien. Gravity pulling toward the center. People upside down in Australia. Oceans curving down. It's psychologically uncomfortable. And discomfort breeds denial. Fast forward to the 19th century. Samuel Rowbotham, under the pseudonym Parallax, revived flat Earth ideas with his zetetic astronomy. He conducted the Bedford Level experiment in 1838 on a 6-mile straight canal in England. He claimed that objects at the far end remained fully visible when, according to spherical geometry, several feet should have been hidden by curvature. Flat Earth proponents still cite this today. But here's the twist. The experiment was flawed from the start. Rowbotham used a telescope with insufficient magnification and ignored atmospheric refraction, the bending of light rays near the warm surface of water, which can lift distant objects into view, creating mirages. When repeated properly with better equipment and accounting for refraction, most famously by Alfred Russel Wallace in 1870, the curvature reappeared exactly as predicted. The distant marker was partially obscured by about 6 feet over 6 miles, matching the 80. This pattern repeats across history. Every time someone claims to have proven flatness with a long-distance line-of-sight observation, the result is either refraction, optical illusion, or deliberate mismeasurement. Modern examples abound. The Lake Balaton laser experiments, the famous 20-mile canal shot videos on YouTube. When repeated under controlled conditions, different times of day, different temperatures, calibrated equipment. The bulge reappears. The flat result is the exception, not the rule. Let's bring this into everyday life with a simple analogy. Imagine you're driving across a very gently curved bridge. So gentle, you can't feel the curve. If you look far enough ahead, the road seems to dip away and disappear behind an invisible hill. That's exactly what happens when you watch a ship sail out to sea. The hull vanishes first, then the superstructure, then the mast. On a flat plane, the entire ship would shrink uniformly until it became too small to see. But it doesn't. The bottom disappears while the top is still visible. Zoom in with a telescope or camera. The hull reappears? No. Once it's gone below the curve, no amount of magnification brings it back. Only when the observer climbs higher, a lighthouse, a drone, a plane, does more of the ship become visible again. That's curvature in action. You can test it at any large body of water. Now let's scale it up to something even more undeniable. Time zones and the Terminator line. At any given moment, exactly half the Earth is illuminated by the sun. The boundary between day and night, the Terminator, is a great circle. On a flat disk with a local sun, illumination would look like a spotlight moving across the plane. The day-night boundary would be a sharp, circular patch. But it isn't. Watch live footage or use any global sunrise-sunset calculator. The Terminator sweeps smoothly across continents in a curved arc. When it's noon in London, it's sunrise in New York, midnight in Tokyo, and sunset in Perth, all simultaneously. On a flat plane, that geometry is impossible without invoking wildly inconsistent light behavior. And here's where the discomfort really sets in. If Earth is round and spinning, then people in Australia aren't upside down. Gravity defines down as toward the center. Australians feel the same pull we do, toward their feet, because their feet point toward the same center of mass. The entire planet is oriented around that center. There is no absolute up or down in space, only radial direction. But let's not stop at optics. Let's talk rotation. In 1851, Léon Foucault hung a 67-meter pendulum from the dome of the Panthéon in Paris. The plane of its swing slowly rotated clockwise over the course of a day, 11 degrees per hour. The same pendulum, taken to different latitudes, rotates at different rates. 360 degrees in 24 hours at the poles, 0 at the equator, and intermediate rates in between. The formula is clean. Rotation rate UA 15 degree HOOS in latitude per hour. This is direct, mechanical proof of Earth's rotation on its axis. A flat, stationary disk has no such effect. Flat Earth explanations usually invoke ether drag or electromagnetic fields, but those are ad hoc, unstable, and contradict every other observation of ether and electromagnetism. The Foucault pendulum is not a museum curiosity. It still swings today in dozens of science centers worldwide. You can visit one, watch it, and see the plane of oscillation drift exactly as predicted by a rotating sphere. No conspiracy required, just gravity and inertia. And yet the central paradox remains. Despite all this, why do some people still believe? Because belief is emotional, not always rational. The flat Earth narrative offers certainty in an uncertain world. It promises that you, the individual, have seen through the greatest lie in history. That feels powerful. But power built on rejecting evidence is fragile. And the evidence keeps accumulating. So here we stand at the end of Act I. We've gone from ancient shadows in wells to pendulums that betray the spin of our planet, from ships disappearing bottom first to time zones that only make sense on a globe. These are not isolated anomalies. They form a coherent, interlocking web of observations that all point in one direction. Earth is an oblate spheroid, rotating once every 23 hours 56 minutes, orbiting a star at 30 kilometers s, embedded in a galaxy of 400 billion stars. But this is only the foundation. What comes next will take us far beyond sticks and shadows, into the sky, into space, into realms where the flat model collapses completely under its own contradictions. The data is mounting, and it is pushing us toward an uncomfortable conclusion. The flat Earth isn't just wrong. It is geometrically, physically and observationally impossible. But that's only the beginning. The real shock awaits when we look higher. When satellites, astronauts, and the cosmos itself begin to speak. Now the evidence begins to pour in like water through a broken dam. We move beyond sticks in the ground and pendulums in cathedrals. We climb higher. We look farther. We listen to signals that have traveled hundreds of thousands of kilometers through the vacuum of space. And with each new vantage point, the flat Earth model doesn't just struggle, it shatters. Let's start where almost every modern person has already stood without realizing it: your smartphone. Inside that slim rectangle in your pocket lives a constellation of proof. GPS doesn't work by magic. It relies on a network of at least 24 satellites, currently 31 operational, orbiting Earth at an altitude of approximately 20,200 kilometers, each traveling at 14,000 kilometers. These satellites continuously broadcast their precise position and the exact time the signal was sent, down to nanoseconds. Your phone receives signals from at least 4 of them, measures the time delay for each, and solves a set of spherical intersection equations to determine your latitude, longitude, and altitude. The entire system is built on spherical trigonometry and general relativity corrections, because time dilation from both velocity and gravitational potential must be accounted for. Einstein's equations predict a 38 microsecond per day difference that would accumulate. Flat Earth models have no coherent explanation for how this works. Some claim ground-based towers do it all, but there are only about 30,000 cell towers in the US, nowhere near enough for global coverage, especially over oceans, deserts, polar regions. And towers can't explain why GPS altitude readings match aircraft altimeters perfectly when flying at 35,000 feet, or why civilian GPS receivers can track positions above 18 kilometers altitude only if they assume orbital mechanics of a round. As it ascends, it doesn't simply shrink into the distance. It arcs eastward, following the curvature of Earth while gaining orbital velocity. If Earth were flat, the rocket would either continue straight up forever or fall back down along a straight line. Instead, within minutes, it disappears over the horizon while still ascending, because the horizon itself is dropping away beneath it. Amateur rocket enthusiasts and high-altitude balloonists routinely capture this. Cameras at 30-40 kilometer altitude show a distinct, razor-sharp curve. The higher you go, the more pronounced it becomes. At 100 km, the Kármán line, the edge of space, the curve is unmistakable, a gentle but continuous arc spanning hundreds of kilometers. Flat Earth proponents sometimes counter with wide-angle lens distortion, but the effect persists with rectilinear, zero distortion lenses, fisheye-corrected footage, and even GoPro footage processed through software that removes barrel distortion. Moreover, the curvature is measurable at 35 kilometers altitude, typical weather balloon height. The geometric horizon distance is about 670 kilometers, and the visible curvature drop from center to edge is roughly 3-4 degrees, easily photographed and consistent across thousands. Let's go even higher, into low Earth orbit itself. Since November 2000, humans have continuously lived aboard the International Space Station at 408 kilometers altitude. More than 260 people from 20 countries have visited. They see the same thing every 90-minute orbit: Earth as a glowing blue marble, horizon sharply curved, continents sliding beneath them like pieces on a slowly turning globe. Live HD video streams are available 24/7. You can watch sunrise over the Pacific, city lights of Europe at night, auroras dancing above the poles, all from a vantage point that only makes sense if you're looking down on a rotating sphere. Skeptics claim it's all filmed in a pool or green screen studio. But consider the scale of such a hoax. Over 3,000 astronauts, cosmonauts, taikonauts, and private flyers, including civilians from SpaceX, Blue Origin, Axiom, Virgin Galactic, would have to maintain perfect silence for decades. Every nation with a space program, USA, Russia, China, India, Japan, Europe, would have to collude. Independent amateur radio operators track ISS passes, decode its voice and packet transmissions, even talk directly to crew members using simple ham radio equipment. If it's a hoax, why do signals come from the exact predicted orbital path? Why can schools and museums bounce laser signals off retroflectors left on the moon by Apollo missions, still measurable today with millimeter precision? Now pivot to another class of observation: the behavior of other celestial bodies. Through even a modest backyard telescope, you can see that Venus, Mars, Jupiter, and Saturn are unmistakably spherical. Their disks show phases, like the moon, limb darkening, enduring opposition, details that rotate with known periods. Jupiter's Great Red Spot has been tracked since the 1660s. Its cloud bands rotate differentially, faster at the equator than at higher latitudes. Classic behavior of a fluid body under conservation of angular momentum on a sphere. If planets are round, why would Earth be the single exception? Occam's razor slices cleanly here. One shape explains everything. And then there is the ultimate smoking gun for many: the view of Earth from the moon. During the Apollo missions, 1969-1972, astronauts photographed Earth rising above the lunar horizon. The famous Earthrise image from Apollo 8 shows our planet half illuminated, hanging in the black sky above a barren, cratered landscape. The Terminator line is curved. The continents are recognizable. The size and position match exactly what orbital mechanics predict for a spacecraft 384,400 kilometers away from a sphere 12,742 kilometers in diameter. Flat Earth models can produce that geometry. No matter how you tilt or position a disk, you can't make a nearby moon see a tiny distant disk Earth rise above its own horizon while showing consistent phase and illumination. But perhaps the most devastating blow comes from something invisible yet measurable: radio propagation and long-distance communication. Amateur radio operators regularly make contacts on HF bands 330 mH2 via skywave propagation, signals bouncing off the ionosphere. The maximum single-hop distance is about 4,000 kilometers, limited by the geometry of Earth's curvature and the height of the reflecting layer, 400 kilometers. If Earth were flat, there would be no geometric limit. Signals could bounce indefinitely, allowing global contacts on low power with no skip zones. But skip zones exist. There are dead zones where no signal arrives. The pattern matches a spherical reflector perfectly. DX, long distance, records, such as working Antarctica from Europe on 160 meters, really on multiple ionospheric hops that only align on a globe. Even more telling, over-the-horizon radar systems, OTH, used by militaries, bounce signals off the ionosphere to detect targets thousands of kilometers away. Their coverage arcs follow great circle paths. Australia's Jindalee operational radar network can see aircraft over Indonesia and parts of the Indian Ocean. Distances and bearings that match spherical geometry and fail utterly on any flat map. And let's not forget Antarctica itself. Flat Earth models usually place Antarctica as an ice wall encircling the entire disk, hundreds of meters high, guarded to prevent anyone from discovering the edge. Yet commercial flights cross the continent regularly. Qantas operates sightseeing flights over the South Pole. Norwegian, British, and American research stations are staffed year-round. Tourists visit the Ross Ice Shelf, McMurdo Sound, the Amundsen Scott South Pole Station. Expeditions ski across the continent. In 2013, a team even bicycled to the pole. No wall, no edge, just 14 million square kilometers of ice, rock, and snow. Curving gently with the rest of the planet, DOT satellite passes over Antarctica show continuous daylight during the austral summer, midnight sun, and continuous darkness in winter, exactly as predicted for a tilted, rotating sphere on a flat plane with a circling local sun. The South Pole would never experience 6 months of darkness. The sun would always be above the plane somewhere. These observations are not cherry-picked. They come from independent sources: commercial aviation, amateur astronomy, ham radio, civilian spaceflight, military radar, polar exploration, consumer GPS, high-altitude photography. Each one independently requires a spherical, rotating Earth. Together, they form an unbreakable chain. And yet, this is still only the surface layer. The deeper we go, the stranger and more decisive the evidence becomes. Phenomena that flat models cannot even begin to address without invoking magic-like mechanisms. Variable starlight, gravitational mapping from orbit, cosmic microwave background, isotropy. The simple existence of seasons at different latitudes with opposite timing in each hemisphere. The picture is growing clearer and more uncomfortable, because these are no longer isolated proofs. They are converging, rapidly, relentlessly, toward one inescapable shape. A shape with no edges, no dome, no wall. A spinning blue world suspended in the void. But the most shocking revelations are still ahead. The deeper we dive, the more the flat Earth model begins to bleed contradictions. What started as a disagreement over shadows and ship hulls now escalates into outright physical impossibility. The consequences of assuming a flat stationary disk aren't just inconvenient, they are catastrophic. They break gravity, light, seasons, magnetism, the entire architecture of the observable universe. And recent observations from the last decade have only widened those cracks into chasms. Let's begin with the single most shocking consequence that flat models cannot escape. Opposite seasons and opposite day lengths in the two hemispheres. Right now, as I speak these words, if it is summer in the northern hemisphere, long days, short nights. Then, it is winter in the southern hemisphere. Short days, long nights. When it is December in New York, the sun rises late and sets early in Buenos Aires or Cape Town or Melbourne. The sun rises early and sets late. Midnight sun circles continuously above Antarctica for weeks. 6 months later, the roles reverse perfectly. On a spherical, tilted, rotating Earth orbiting the sun, this is trivial geometry. The 23.44-degree axial tilt causes one pole to lean toward the sun, while the other leans away. The circle of illumination sweeps differently across each hemisphere. Simple, predictable, matches every weather record, every agricultural calendar, every sunrise, sunset table ever published. Now try to force that same behavior onto a flat disk with a local, close sun. The standard flat Earth model places the sun at roughly 5,000 kilometers altitude, about 50 kilometers in diameter, acting like a spotlight. To produce long northern summer days, the sun must spiral slowly outward from the North Pole center, toward the Tropic of Cancer radius. To shorten southern days at the same time, it must somehow spend less time over the outer rim. But the sun cannot be in two places at once. If it is circling high and slow over the north to give 16-hour days in Scandinavia, it is far from Antarctica, meaning the entire southern disk should be in darkness. Yet it isn't. Southern cities enjoy 14-15-hour daylight at their summer solstice. Flat Earth counters usually invoke perspective, or vanishing point, or light confinement. The sun's rays somehow bend or stop illuminating beyond a certain distance. But these are desperate patches. Light does not behave that way in vacuum or atmosphere. We have measured solar irradiance globally. It drops with the cosine of the zenith angle, Lambert's cosine law. Exactly as on a sphere. If the sun were a close spotlight, irradiance would fall off much more rapidly with distance, following an inverse square law from a point source. Yet solar panels in Antarctica during summer solstice receive nearly the same energy per square meter as panels in the Arctic. The numbers match a distant sun, 149.6 million kilometers away, illuminating a tilted sphere, not a tiny lamp 5,000 kilometers overhead. The contradiction grows sharper with equinoxes. On March 20, 21 and September 22, 23. Every location on Earth experiences almost exactly 12 hours of daylight, within minutes, adjusted for refraction. The terminator becomes a perfect great circle passing through both poles. On a flat plane, equinox would require the sun to trace a path exactly halfway between center and rim. Yet that path would still produce unequal day lengths at different radii, unless the sun magically changes speed or size. No flat geometry delivers simultaneous 12-12 everywhere without invoking impossible light bending. But the real devastation comes when we examine stellar observations from both hemispheres. In the north, Polaris sits almost motionless at the celestial pole, altitude equal to your latitude. Stars circle it counterclockwise. In the south, there is no single bright pole star, but the south celestial pole is revealed by the rotation of the Southern Cross and Sigma Octantis. Stars there wheel clockwise around a point invisible near the horizon from mid-northern latitudes. On a flat Earth with stars affixed to a rotating dome or projected above, both hemispheres should see roughly the same sky, just mirrored or shifted. But they don't. The northern observer never sees Alpha Centauri, the Southern Cross, or the Magellanic Clouds. The southern observer never sees Polaris, or the Big Dipper circling high overhead. The two skies are mutually exclusive, separated exactly as if an opaque sphere blocked half the view from each side. The only mechanism that naturally produces two separate, oppositely rotating celestial hemispheres is a spherical observer standing on the outside of a rotating ball. Flat models require an invisible barrier, selective transparency, or complex projection mapping that no proponent has ever mathematically formalized or observationally demonstrated. Now let's turn to one of the most recent and brutal nails in the coffin: airborne and space-based gravimetry. Since the early 2000s, satellites like GRACE 2002, 2017, and GRACE-FO 2018 present have mapped Earth's gravitational field with unprecedented precision. Flying in tandem at 490 kilometers altitude, they measure minute changes in distance between them down to micrometers, caused by variations in Earth's gravity. The data reveal a beautiful oblate spheroid. Stronger gravity at the poles due to closer proximity to the center of mass. Weaker at the equator due to centrifugal force and equatorial bulge. Mountains show positive gravity anomalies. Ocean trenches show negative. The geoid, the equipotential surface we call sea level, is lumpy, pear-shaped, exactly as general relativity and Newtonian gravity predict for a rotating fluid body in hydrostatic equilibrium. A flat disk, even a thick one, cannot produce this pattern. Gravity on an infinite plane is constant with altitude, Gauss's law for gravity, and varies linearly only near edges. A finite disk would have gravity pulling sideways near the rim. People at the Antarctic ice wall would feel pulled toward the center, not straight down. No such lateral force is measured anywhere. Gravimeters on ships crossing the Southern Ocean show gravity increasing smoothly toward the pole, then decreasing symmetrically on the other side. Precisely the signature of a sphere. The GRACE maps are public. You can download them. They match GPS, satellite laser ranging, and surface gravimetry to within microgoules. Flat Earth attempts to dismiss them usually fall back on NASA lies without offering an alternative model that reproduces the data. And then there is the quiet killer, the simple existence of circumpolar flights in the south. Commercial routes now regularly fly Johannesburg to Sydney, Qantas QF63, 11,300 km, 12-14 hours. Auckland to Santiago, Perth to Johannesburg. On the azimuthal equidistant flat Earth map, the most common projection used by proponents, these routes should be absurdly long, doubling or tripling actual distances, because Australia, South America, and Africa are stretched grotesquely around the outer rim. Yet actual flight times, fuel burn, and great circle routes match spherical trigonometry perfectly. No flat map preserves both distances and bearings simultaneously. The famous distance problem of map projections. In 2021, 2025, even more southern routes opened. Direct flights from South Africa to South America over Antarctica. Tourist overflights of the pole. Private expeditions. Pilots and passengers photograph the curved horizon at 35,000, 41,000 feet. The view is the same gentle arc seen from northern polar flights. No ice wall, no forbidden zone, just white expanse curving away in all directions. The most shocking recent revelation ties everything together: the 2020-25 revival of high-altitude pseudo-satellites HAPS, and stratospheric balloons carrying 4K cameras. Projects like Google Loon ended 2021, Airbus Zephyr, Bay Systems FASA 35, and countless university and citizen science balloons have sent lightweight platforms to 20-25 km for weeks at a time. Almost all publish uncut, time-stamped footage. The curvature is constant, independent of lens. As altitudes, the horizon spans 800 km. Far too wide for any lens distortion to fake a curve that smoothly matches spherical trigonometry. And when these platforms drift across the equator, the star fields change exactly as predicted. Northern constellations sink, southern ones rise. This is no longer 1960s film stock or government-controlled imagery. Doubt. These are open-source, crowdsourced, independently verified datasets. The flat model has nowhere left to hide. So here we arrive at the precipice. Every consequence we examine, opposite seasons, mutually exclusive skies, satellite gravimetry, southern great circle routes, stratospheric curvature footage, points outward from the flat disk towards something far grander. These proofs don't just disprove a flat Earth. They demand a rotating globe orbiting a distant star in a universe of billions of galaxies. And that demand leads us somewhere dizzying. Because once you accept the sphere, you are forced to confront the next layer of strangeness. We are not the center. We are not special. We are a fragile, temporary speck clinging to the surface of an average planet, circling an average star in the quiet arm of an average galaxy. The flat Earth fantasy keeps us safely at the center of a small, domed cosmos. The spherical reality hurls us into the abyss and into wonder. But we are not done. The biggest shocks still lie ahead. When we leave the atmosphere entirely and stare into the face of the cosmos itself, we have reached the point where denial becomes mathematically unsustainable. Every observation we have examined, from Eratosthenes' shadows to gray satellites mapping gravitational lumps, from southern circumpolar star rotation to stratospheric balloon footage showing consistent curvature, converges on one elegant, unified explanation. That explanation is not a conspiracy. It is not a government program. It is a physical model that has been refined over more than 2 millennia and stress-tested by every new technology humanity has invented. The theory is simple in outline, breathtaking in implication. Earth is an oblate spheroid, an almost perfect sphere slightly flattened at the poles and bulging at the equator by about 43 kilometers due to its daily rotation. Its equatorial diameter is 12,756 km. Polar diameter 12,714 km. It rotates once every 23 hours, 56 minutes, and 4 seconds, a sidereal day, on an axis tilted 23.44 degree relative to its orbital plane around the Sun. That orbit takes 365.256 days at an average distance of 149.6 million km. 1 astronomical unit. The Sun is a main sequence G2 of a star, 1.391 million km, 333,000 times more massive than Earth, fusing hydrogen into helium at its core and releasing energy that has bathed our planet for 4.6 billion years. This model, known today as the heliocentric, Newtonian, Einsteinian framework, is not one person's opinion. It is the synthesis of contributions from dozens of the greatest minds in history. Aristarchus of Samos, c. 310, 230 BCE, first proposed heliocentrism. Copernicus, 1543, revived it mathematically. Kepler, 1619, discovered elliptical orbits and the laws of planetary motion. Galileo, 1610, observed Jupiter's moons, Venus phases, and the rugged surface of the moon. Direct evidence against the Ptolemaic geocentric model. Newton, 1687, unified terrestrial and celestial mechanics with universal gravitation. Cavendish, 1798, measured the gravitational constant, allowing calculation of Earth's mass. Einstein, 1915, replaced Newton's force with space-time curvature and general relativity. Still the most accurate description we have. Modern teams. LIGO Virgo Cagra collaboration, 2015 present. Detecting gravitational waves, Event Horizon Telescope, 2019-2022. Imaging black hole shadows, James Webb Space Telescope. No serious scientific body on Earth disputes this framework. The International Astronomical Union, American Physical Society, European Space Agency, Chinese National Space Administration, Indian Space Research Organization, Roscosmos, all operate under exactly the same spherical, rotating, orbiting Earth model. If it were wrong, GPS would fail, weather satellites would mispredict hurricanes, interplanetary missions, Voyager, New Horizons, Perseverance, Change, Bepi Colombo, Psyche, Europa Clipper, would miss their targets by millions of kilometers. They don't. They arrive within meters after journeys of years. Now consider the leading alternative, the flat Earth model in its most commonly presented form. Azimuthal equidistant projection, North Pole at center, Antarctica as ice rim, local sun and moon, 5,000 km up, stars on a dome or firmament. This model fails at every scale. It cannot produce opposite seasons, an opposite sidereal rotation of stars without contradictory sun paths. It cannot explain gravitational variation, stronger at poles, weaker at equator, without lateral forces that would throw objects sideways near the rim. It requires light to bend in physically impossible ways to hide the supposed ice wall and to create artificial horizons. It violates conservation of angular momentum. No natural mechanism exists for the differential stellar rotation between hemispheres. It has no predictive power, no equations for sunrise-sunset times, no formula for star altitudes by latitude, no way to calculate satellite passes or rocket trajectories. It contradicts basic optics. Sunsets would never show the sun dipping below the horizon. Instead, it would shrink and fade while remaining fully above the plane. Alternative flat models, infinite plane, accelerating disk, concave Earth, cellular cosmology, etc. fare even worse. They introduce more contradictions than they solve and lack any quantitative framework. Philosophically, the spherical model forces humility. We are not at the center. We are not enclosed in a special dome. We are one planet among trillions, orbiting one star among hundreds of billions, in one galaxy among at least 2 trillion. This realization can feel existentially unsettling. Carl Sagan called it the pale blue dot effect. Yet it also opens awe. Every atom in your body was forged in stars. The same physics that curves space-time around black holes curves the path of a baseball. The universe is not capricious. It is lawful, comprehensible, and, most remarkably, knowable through patient observation. The flat Earth view, by contrast, promises comfort. We are special, central, watched over by an enclosing firmament. But comfort purchased by rejecting evidence is brittle. When Voyager 1, launched 1977, crossed the heliopause in 2012, and entered interstellar space, when Juno arrived at Jupiter in 2016, and imaged its polar cyclones, flat models made no such predictions and offered no corrections when the missions succeeded. This is the decisive asymmetry. One framework makes quantitative, risky, successful predictions across centuries. The other offers post hoc excuses. And yet, the philosophical weight remains heavy. Accepting the globe means accepting that humanity has spent millennia climbing out of illusion. From geocentric Ptolemaic epicycles to heliocentric ellipses to relativistic spacetime, each step required letting go of egocentric intuition. The flat Earth resurgence is, in part, a backlash against that hard-won humility, a desire to return to a simpler, more anthropocentric cosmos. But the universe does not care about our comfort. It simply is. And what it is, according to every convergent line of evidence, is a vast, four-dimensional space-time arena in which a small, rocky world spins and orbits in quiet obedience to the same laws that govern quasars 10 billion light-years away. This forces us to reframe our place entirely. We are not the stage. We are players on one tiny platform in an endless theater. That realization can terrify or liberate. Because if the laws are universal, then the curiosity that drives us here can, in principle, reach anywhere. The same minds that measured Earth's circumference with sticks now image atoms, detect gravitational waves from colliding neutron stars, and plan missions to the moons of Jupiter and Saturn in search of life. The theory is not just about shape. It is about method, about trusting evidence over intuition, about building knowledge incrementally, correcting ourselves when wrong, and celebrating when right. And we are right about this. Earth is round. It spins. It orbits. We are moving. Fast. through a cosmos that is almost inconceivably large and old. But accepting that truth does not end the story. It opens the next chapter. What happens when we turn our instruments outward? Not just at our little world, but at the deep structure of reality itself. The future missions, the next generation telescopes, the experiments already running. They are about to show us things even more profound than a spinning globe. They are about to reveal whether we are alone, whether gravity has secrets we have not yet unlocked, whether the universe itself has edges, beginnings, or endings we can't comprehend. The big picture is no longer about the shape of Earth. It is about the shape of everything. And that picture is still being painted. We stand at the threshold of something unprecedented. The same tools and methods that once proved Earth is round, careful measurement, repeated observation, fearless correction, are now turning outward, probing questions far larger than the shape of our planet. In the coming decade, missions, telescopes, detectors, and experiments already funded and under construction will deliver data that could redefine not just our place in the cosmos, but the very nature of reality itself. Let's begin with the instruments already watching the sky. The James Webb Space Telescope, JWST, launched in December 2021, continues to shatter records. By mid-2025, it had imaged galaxies formed less than 300 million years after the Big Bang, detected carbon dioxide in the atmosphere of a temperate exoplanet, WASP-39b, and later TRAPPIST-1 system candidates, and revealed auroral emissions on brown dwarfs and methane. Its near and mid-infrared vision pierces dust clouds that hide star-forming regions and early universe structures. Every new release forces cosmologists to recalibrate models of galaxy formation, dark matter distribution, and the reionization epoch. If JWST continues at this pace through the late 2020s, we may finally settle whether the Hubble tension, the discrepancy between local and cosmic microwave background measurements of the expansion rate, points to new physics, perhaps modifications to general Closer to home, the Vera C. Rubin Observatory, Legacy Survey of Space and Time, LSSD, began full operations in 2025. Located in Chile, its 84-meter mirror and 3.2 gigapixel camera will scan the entire visible sky every 3 to 4 nights for a decade. It is expected to discover millions of new asteroids, supernovae, variable stars, and transient events, while mapping dark matter through weak gravitational lensing across billions of galaxies. The sheer patterns in distant galaxy shapes will produce the most detailed dark matter map ever made, potentially revealing whether dark matter is cold, warm, self-interacting, or something stranger. If anomalies appear in the lensing statistics, they could hint at primordial black holes, axions, or modified gravity theories that challenge the standard GONT-TM model. In radio astronomy, the Square Kilometre Array, SKA, under construction in Australia and South Africa, will begin early science in the late 2020s. With collecting area equivalent to a square kilometer and baselines spanning thousands of kilometers, SKA-Low and SKA-Mid will map neutral hydrogen across cosmic time, probe the epoch of reionization, search for technosignatures, artificial radio signals. The 2023 nanograph evidence for a stochastic gravitational wave background may be confirmed or refuted with orders of magnitude better sensitivity, potentially opening a new window on the early universe or exotic objects like cosmic strings. Space missions are moving even faster. NASA's Europa Clipper, launched in October 2024, will arrive at Jupiter in 2030 and perform dozens of flybys of Europa, sniffing for salts, organics, and possible plumes erupting from its subsurface ocean. If amino acids, complex hydrocarbons, or redox disequilibria are detected, the case for extraterrestrial habitability in our own solar system strengthens dramatically. Concurrently, ACE's JUICE, Jupiter Icy Moons Explorer, launched 2023, will reach the Jovian system in 2031 and study Ganymede, Callisto, and Europa in detail, potentially confirming whether any of these moons harbor liquid water in contact with. Further out, Dragonfly, a rotorcraft lander mission to Titan, launches in 2028 and arrives in 2034. It will fly across the moon's dunes, land multiple times, and analyze prebiotic chemistry in methane lakes and organic-rich sands. Titan's thick atmosphere and surface liquids make it the most Earth-like world we know besides our own. Dragonfly could tell us whether the building blocks of life can assemble and persist in environments radically different from Earth's. Closer to home still, private industry is accelerating the pace. SpaceX's Starship program, by 2026, has demonstrated orbital refueling and is targeting crewed lunar landings, Artemis III follow-ons, and Mars cargo missions in the early 2030s. Starship's massive payload capacity, over 100 tons to low Earth orbit, changes everything. Large space telescopes, lunar bases, Mars habitats, asteroid mining prototypes become feasible within a single launch window. If Starship achieves full reusability at scale, the cost per kilogram to orbit could drop below $100, democratizing access to space in ways unimaginable a decade ago. Blue Origin, Rocket Lab, and others are developing heavy lift and in-space manufacturing capabilities. Meanwhile, orbital laboratories like Axiom Station plan to attach to IS before transitioning to free flying. And Starlab will host continuous human-tended research, including protein crystal growth, 3D bioprinting, and material. On the ground, quantum sensors and atom interferometers are reaching new precision. Projects like MAGIS 100, Mid-Latitude Atomic Gravitational Wave Interferometric Sensor, and ELGER, European Laboratory for Gravitational Research, aim to detect mid-frequency gravitational waves from intermediate mass black hole mergers or early universe phase transitions. Tabletop experiments using Bose-Einstein condensates and optical lattices are already measuring gravity at micron scales with unprecedented accuracy, potentially revealing deviations from Newtonian gravity that could point to extra dimensions or dark sector particles. And then there is the ultimate frontier, the search for life beyond Earth. The Nancy Grace Roman Space Telescope, Launch E227, will conduct the widest, deepest infrared survey ever attempted, hunting for thousands of exoplanets via microlensing and directly imaging giant planets in reflected light. Plato, Launch 2026, and Habitable Worlds Observatory Concepts, NASA, 2040's target, will search for Earth-like planets in habitable zones and analyze their atmospheres for biosignatures, oxygen, methane disequilibrium, seas. Breakthrough Listen and other SETI efforts continue scanning millions of stars for narrowband technosignatures. If even one unambiguous artificial signal is found, or if we detect unambiguous biosignatures in an exoplanet atmosphere, the philosophical shock would dwarf the Copernican revolution. We would know we are not alone. Or, conversely, if decades of increasingly sensitive searches yield only silence, the Fermi paradox deepens, forcing us to confront whether intelligent life is vanishingly rare, self-destructive, or simply uninterested in communication. These are not distant dreams. Most of the missions and observatories named are already built, funded, or in advanced assembly as of 2026. The data pipeline is open. The discoveries are incoming. And here is the most exhilarating part. Every one of these instruments assumes, indeed requires, the spherical, rotating, orbiting Earth we have defended throughout this journey. The orbital mechanics for WSD at L2. The timing corrections for pulsar arrays. The trajectory planning for Europa Clipper and Dragonfly. The light travel time calculations for exoplanet transits. All collapse if Earth is flat. The fact that these missions succeed spectacularly is the ultimate real-time validation of the globe model. We are not just proving Earth is round anymore. We are using that proven roundness as a launchpad to ask, are we alone? Is gravity fundamental or emergent? Does the universe have a boundary, or is it infinite? Did it have a true beginning, or is time itself an illusion at the Planck scale? These questions are no longer confined to philosophy departments. They are encoded in gigabytes of data already streaming from orbit, from mountaintops, from underground detectors. The pace is accelerating. The tools are sharper than ever. The next 10 to 20 years may deliver answers, or at least radically better questions, that reshape civilization. Not bad for a species that once argued whether the ground beneath our feet curves. The scale has shifted from the size of our planet to the size of existence itself, and we are only just beginning to look. We have traveled far, from a stick casting a shadow in an ancient Egyptian well, to satellites mapping the invisible lumps in Earth's gravitational embrace, to telescopes that can peer back almost to the moment the universe became transparent. We have built an unbreakable chain of evidence. Every link confirms the same truth. Earth is not flat. It is not stationary. It is not the center of anything. It is a small, spinning, rocky world. Beautiful, fragile, alive, hurtling through space at 107,000 kilometers h, around a medium-sized star in the quiet suburbs of an unremarkable galaxy. But arriving at this conclusion is not the end. It is the beginning of far deeper, more unsettling, and more exhilarating questions. What does it really mean that our home is a sphere, suspended in nothing? The most immediate, visceral implication is scale. When you stand on a beach and watch the sun dip below the horizon, you are witnessing geometry in real time. 12,742 kilometers of curved surface dropping away at roughly 8 inches per mile squared. That tiny daily event connects directly to the fact that light from the Andromeda galaxy, 2.5 million light-years away, has been traveling toward your eyes for 2.5 million years. The same curvature that hides ships also hides entire star systems, until we build instruments sensitive enough to catch their faint glow. This linkage is not poetic metaphor. It is physics. The mathematics that predicts a sunset at 6:47 p.m. local time on July 15 is the same mathematics that plotted Voyager 1's trajectory out of the heliosphere in 2012. The equations that keep GPS satellites in their 20,200-kilometer orbits are descendants of the equations Newton wrote while watching an apple fall. One continuous thread of reason ties the curve of the horizon to the structure of the cosmos. And that thread leads to the most profound existential shift of all. Copernican decentering, extended across every dimension. We are not at the spatial center. We are not at the temporal center. The universe is 13.8 billion years old. Modern humans have existed for 0.004% of that time. We are not chemically special. Every element heavier than lithium was forged inside stars. We are not even biologically guaranteed, as far as we know today. Earth is the only place where life arose and persisted long enough to produce minds capable of asking these questions. This cascade of not special realizations can feel like vertigo. The flat Earth idea and every pre-Copernican cosmology offered psychological shelter, enclosure, centrality, purpose built into the architecture of reality itself. A dome overhead, an ice wall at the edge, a local sun circling above us like a divine spotlight. It is comforting architecture. The spherical, heliocentric, galactocentric, cosmological reality offers none of that. Instead, it offers something harder and, arguably, more beautiful, radical connectedness. Every atom in your body was once inside a star that exploded. The iron in your blood was synthesized in the cores of supernovae, whose light may have reached Earth before complex life even existed. The water in your cells likely contains molecules that condensed in the cooling ejecta of those same explosions, were incorporated into planetesimals, survived the violent birth of the solar system, and eventually found their way into the oceans of early Earth. You are not separate from the universe. You are the universe experiencing itself, temporarily organized into a pattern complex enough to reflect, to question, to feel awe. That is the deepest implication of accepting a round, spinning, orbiting Earth. It is not diminishment. It is magnification. But magnification brings shadows too. If the laws are universal, if physics operates the same 13 billion light-years away as it does in this room, then the silence we hear when we listen for other minds, the Fermi paradox, becomes sharper. Where are they? Why does the galaxy not hum with megastructures, radio beacons, self-replicating probes? Possible answers range from the hopeful, we are simply early, or they communicate in ways we cannot yet detect, to the sobering intelligent life is vanishingly rare, or it inevitably self-destructs, or it chooses silence for survival. Recent years have tightened the constraints. The lack of obvious Dyson swarms in infrared surveys, G-HAT, breakthrough listen ancillary projects, the absence of obvious artifacts on the Moon, Mars, or in the asteroid belt, despite high-resolution imaging from LROA, Emerald, Osiris, Rex, Hayabusa 2 The continuing null result from SETI searches across billions of frequency channels and millions of stars. We do not know which scenario is correct, but we are closing in. Here are 4 plausible futures that current trajectories suggest, each carrying massive implications. The quiet universe. Continued deep silence. No biosignatures in the first 1,000 habitable zone atmospheres analyzed by WST, Roman, Plato, habitable worlds. No technosignatures in SCA or next generation SETI. We conclude, provisionally, that complex life is extraordinarily rare, perhaps a 1 in 10 event. Earth is not just special, it may be singular. That knowledge would be both devastating and sacred. We would carry the responsibility of being, as far as we know, the only eyes and minds the universe has yet produced. The biosignature breakthrough. Within the next 10, 20 years, a clear combination of oxygen, methane, or other disequilibrium gases is detected in the transmission spectrum of a rocky exoplanet in the habitable zone. Follow-up confirms seasonal variation, consistent with photosynthesis-like processes. We would know life is common, at least microbial life. The philosophical earthquake would be immense. Biology is a cosmic phenomenon, not a fluke. The urgency to protect Earth's biosphere would skyrocket. The technosignature detection. A narrow band, modulated, non-natural radio signal, or an unambiguous megastructure signature, waste heat, artificial transit anomalies, laser pulses, or an artifact in our own system. Confirmation would rewrite history overnight. We would no longer be alone. The questions of contact protocols, cultural contamination, existential risk from advanced others would dominate global discourse for generations. New physics before contact. Before we find life or intelligence elsewhere, we find cracks in our current understanding. Gravitational anomalies at laboratory scales, deviations in dark matter behavior, hints of extra dimensions or variable constants. These discoveries could either make contact more likely by revealing new communication channels, or render it irrelevant by showing that our current search paradigm misses most possibilities. Whichever path unfolds, one thing is already certain. The round Earth truth was merely the first door. Behind it lie questions about origins, about consciousness, about whether the universe is deterministic or participatory, about whether mathematics is discovered or invented, about whether anything resembling purpose can emerge from blind laws. We may never answer all of them, but we will keep asking, because that is what minds on spinning spheres do. And now we return to where we began. Imagine again that flat, endless plain. The sun, a local lamp. The stars, a rotating canopy. A wall of ice at the boundary. A small, safe, central world. Then open your eyes. See the ship's vanished hull first. Feel the Foucault pendulum drift beneath your feet. Watch the Southern Cross wheel in the opposite direction from Polaris Tau. Track a Starlink train crossing the sky. Satellites your phone uses to tell you exactly where you stand on a curved surface. Look at the photographs from 400 kilometers up, Earthrise over the moon, the thin blue line of atmosphere hugging a ball of ocean and cloud and land. The impossible observation was never the round Earth. The impossible observation was believing it could be otherwise. We now know, with a confidence earned through centuries of ruthless testing, that the blue marble is real, that it spins, that it orbits, that it is one world among uncounted trillions. And yet, in knowing this, we lose nothing of wonder. We gain everything. The universe is vaster than any dome could contain. Its mysteries are deeper than any wall could guard. Its beauty is fiercer than any comforting story could tame. Our journey, your journey, has only just begun. Thank you for walking this path with me. Keep looking up. The stars are waiting.